So now I want to demonstrate something important that happens when you start running a bit of juice through these things and you've got microprocessors. I'll transmit it's about 100 watts, and you'll see if I do this a few times and I adjust the inductance, you'll see the display might go a bit funny. Oh, so far nothing. Got up the power a bit. So the display's gone funny. So that took a little while. I had to go to something else. I'm running about 150 watts at the moment. Now, the reason for that is that there's interference, there's voltages getting picked up by some of the wiring. So what I'm going to show you in a minute, so I'm going to put a ferrite tube across the wires that go into the stepper motor. So I've now put a clamp over the stepper motor wiring, and I can do the same test again, and you'll see that the display doesn't get corrupted. So now under the same conditions, same power, I can now key the linear on and off and do a little bit of a tweak on some things, and the display doesn't get corrupted, and seems to be okay even at the higher power. At the moment I'm only running 100 watts. I don't want to create too much noise at the moment, but it will run to the tuner will handle 400 watts without any trouble at all. What I can do, I can ramp it up, and you can watch the power meter, see what happens. There we go, that's 400 watts there. And dummy load, it's on a 1000 watt setting. Notice SWR went up, it's quite a bit, so there needs to be a fine trim done, but it's best to try and do that at lower power first. So drop the power a bit, and go down, switch off the dummy load and go down a bit, maybe there somewhere, and then just do a bit of a trim. Quite a lot of juice there now. There we go. Get a better, a more accurate and see in. Go down. There we go. Now we can probably up the power a bit. Yeah, now we're hitting 400 watts there. You can see now. I can use the fine control for that. See that, and go back to see out. There you go. With the fine control, get it right down, see in. It's not really a good idea to tune up at 400 watts, but the thing handles it quite nicely. Doesn't seem to have any problem at all. Here's a quick view of the inductor system. That's the minimum amount of inductance. One lead on, and 2 leads means 2, 3, 4, and so on. It's a binary sequence all the way. Now these leads are across the relays, or across the circuitry driving the relays. When all the leads are on, all of the inductance is in circuit. It basically becomes an RF choke actually. Most of the time I find that it only needs a few turns to match this particular antenna. It'll be different with different antennas, of course. Here's a view of the Stockton bridge. 2 coils using T108s or something, about an inch. And then this particular coil is the phase discriminator. It's a bifilar winding of 2 wires, about 20 turns or so. The RF goes through the center, and either end of the coil goes to 2 diodes, which gives you the phase. And the phase discriminator is normally used if you want to automate the system, because you get a fairly positive indication of which way to go. This is the rear. This is where the power comes in, fuse, battery, a couple of controls to switch rigs and antennas, and then down the bottom here we have the input from the linear, dummy load, and the signal going off to the antenna. And I put a couple of spare connectors there in case I want to do extra antennas or something straight out of the box. There's the electronics, a lot of wiring there. There's going to be a cover over all that, and that cover will help reduce some of the pickup. At the moment this clamp on choke seems to be doing alright, but with such a big box, such giant capacitors, at 400 watts it's hard to stop stuff getting into the processor. However, I do have a switch which turns the processor and everything off, but latches the last values, and the latches seem quite robust. I don't seem to mind, and that means that the inductor stays where you put it. The capacitors won't move, they're mechanical, they're on motors, so nothing's going to happen to them. So once you've found your position, you can turn the processor off and any noise you might hear on any of the rigs, and at the same time the display gets cleaned up. These are the relays. That's the bypass relay. That one down there is the dummy load relay. They're 8 and 10 amps. Their voltage rating is over 250 volts. The dummy load one's rated at 385 volts RMS. More than adequate. The voltage at 400 watts, the peak to peak voltage is nearly 400 volts, but you're only interested in the peak volts because the negative half and the positive half are the same. So as long as the contact ratings can handle a peak value of around 300 volts, then you should be okay. That relay is 385 RMS, and this one here is 250 volts RMS, but in this case there are two contacts in series, plus they're also in series with the capacitors, which also add an additional gap. So there's no problem with a 250 volt gap on the bypass relays. It's well and truly enough. That's the bottom of the relay system. You'll see, put my finger over the lead, the RG, the thicker RG cable goes to the various connectors, and there's some very short wires here that go to the capacitor in and capacitor out. They're only a few inches long, and that's why this whole circuit board with the bypass relay is put very close to the back of the capacitor. There's a view of the capacitors doing their merry dance. I'll do that again. Hear the noise come up on the rig as it tunes the antenna up. Well, that's it. Quick look. Seems to work okay at the higher power. I haven't had any major sparks or arcs or anything like that. The only main problem I had is the display going a bit funny when it picks up RF. But I think better shielding. Certainly the clamp-on thing has reduced it almost to, well, you know, I don't see it since I did that, but that's not to say it's not going to happen on other antennas or other situations. However, it's not a big deal because you can always switch that display off.